So we're going to go over a little review of solving rational equations. So the main tool to solve rational equations is going to be the cross product, or sometimes called cross multiplication. What it says is if we have two fractions, so let's say we have the fraction a over b, and that's equal to the fraction c over d, then if I were to cross multiply, in other words, multiply a times d and multiply b times c, so I can write that out as as a times d, and the other cross product was b times c. And if these fractions are equal to each other, then those cross products should be equal. So that's like a quick example with a real fraction. Like we know that 1/2 is the same thing as something like 9/18. So if we multiply this way, 1 times 18, that is going to be equal if we multiply it the other diagonals, which is 2 times 9, which is also 18. So we do see that if fractions are equal to each other, then they have equal cross products. As we start to move into equations that are more algebraic, we see something like this. Let's pretend 3 over x is equal to 5 divided by x minus 2. So if we see that we have one fraction equal to one fraction, our tool to solve this type of equation is our cross product, or using cross multiplication. So again, just repeating, if I were to take these two things and multiply them together, it's just important to use our parentheses so we know that the entirety of x minus 2 is being multiplied by 3. And if I multiply those other two, 5x, they should be equal to each other. So here I can distribute my 3, so I get 3x minus 6 is equal to 5x. And then we have to solve some type of equation, whether it be linear or quadratic. So here we'll get all the x's on the same side, and then we will divide both sides by 2 to get x alone. So we get negative 3 is equal to x. And we always need to check our work. So 3 divided by negative 3, is that going to be equal to 5 over negative 3 minus 2? So we'll simplify this side just to be negative 1. Here we get 5, and on the bottom this is negative 5. So 5 divided by negative 5 is also negative 1. So this is our answer. So as we move forward, we need to just remind ourselves that if we see multiple fractions on one side of the equal sign, kind of like we do over here, how there's two fractions on this side, and on the other side there's only one, and there could be more than two, maybe 3, or there could be 2 on each side or something like that. If we have a situation like that, we cannot use the cross product. We can only use the cross product if we have one fraction on the left side equal to one fraction on the right side. So the next step is going to be looking at 2 different ways that we can handle problems like this. So the first way that we can handle a problem that we see that has multiple fractions on one side, like this one has 2 fractions on the left side, is we can simply try to combine those multiple fractions using addition or subtraction. So here, if I want to combine these 2 fractions, I just need to get a least common denominator between the 2. And the least common denominator between 3 and 2 is going to be the number 6. So I'd multiply this by 2, I'd multiply that by 2, so I get 2x over 6. And then here I'd multiply the top and the bottom by 3. Plus 3 over 6. I'm just going to keep the right side, again, as 3x. But now once these have a common denominator, the purpose of doing that was that we can combine them together into one fraction. So they keep their denominators, and we add the numerators. And then at this point, when we have one fraction equal to another fraction, now we can use the cross product. So again, the first method was just adding or subtracting fractions, so we could go back to the method that we started with. So we can use our cross product here now. So it means 6 times 1, I'm going to show my work up here. 6 times 1 should be the same thing as multiplying these two together, which was 3x times 2x plus 3. And again, if these fractions are equal, the cross product will be equal. So we get 6 is equal to 6x squared plus 9x. And once we see a quadratic term, we should get it equal to 0. So 0 will equal 6x squared plus 9x minus 6. And at this point, we're going to try to factor that quadratic. I notice there's a GCF of 3 between all these terms. Oops. So if I factor out the 3, we will get 2x squared plus 3x minus 2. And then we'll continue to factor that quadratic. I know that it's going to start with a 2x and an x. And if I put a positive 2 right there and a negative 1 right there, I will get positive 4x's and negative 1x's, which will combine to be 3. So I know I have my factorization correct. So one of these factors must be 0. Obviously 3 was not the reason that we got a 0. So maybe 2x minus 1 was equal to 0, in which case we would see that x would equal 1/2. And then maybe this factor could have been equal to 0 too. So if we tried that, we would see that x was equal to -2. And as always, we need to check our answers to make sure they work. So let's check first. I'll do that in our red color. Let's check x equals -2 in the original problem. So -2 over 3 plus 1/2 should equal 1 over 3 times -2. So -2/3 plus 1/2. Let's just get a common denominator on that right away. And we'll use 6 there so we can see if these fractions are equal. So we'll multiply this by 2 and this by 2. So -4 over 6. So then here again we multiply 3 by 3 over 6 should equal 1 over -6. So here we get -1 over 6 is equal to -1 over 6. So that solution checks out. We do have to check our other solution of 1/2. So if we check 1/2, we get 1/2 divided by 3 plus 1/2 should equal 1 over 3 times 1/2. So with this fraction here, instead of dividing by 3, I'm going to multiply by the reciprocal. And then same thing over here. This is going to be 1 divided by 3/2. So this is 1/6 plus 1/2. And again, here we'll multiply by the reciprocal, which is 1 times 2/3. So continue my work, 1/6 plus 3/6 should equal 2/3. So we have 4/6 is equal to 2/3. And that is a correct statement. So both of these are solutions, so I'm going to indicate that they both work. So going through the same equation, there is one other method that we can use to solve an equation that has multiple fractions on one side. Method number 2 we like to call the sweep method because we actually get rid of all the fractions. So the first thing we would need to do for this method is identify the least common denominator of all terms. So 3, 2, and 3x, the least common denominator of all of those terms, I believe would be 6x. So we're going to multiply every term by 6x. And if it helps us with a fraction, 6x over 1. So 6x times x, and then on the bottom we'd have 1 times 3. If we multiplied this term by 6x over 1, we would have gotten 6x times 1 over 2. Then we're just keeping our equal sign. I'd have to multiply this last term. So on top it would be 6x times 1, and the bottom it would be 1 times 3x. And after we do that, we should be able to reduce the fractions away. Now, if something doesn't go away, then you have the wrong common denominator. So like here, 6 and 3 just reduce to a 2. So this turns into 2 times x, which is just 2x squared. In this fraction, the 6 and the 2 would reduce to a 3. So we have a 3x, and I'm just not choosing to multiply times 1. Then we have our equal sign, and on the right side, the 6 and the 3 can reduce to a 2. This x will cancel with that x, so it's just equal to 2. Now this equation looks a little more simple, so if it's quadratic, we can get it equal to 0. But notice we don't have any more fractions to work with, so we are simply solving a quadratic equation without having to work with the fractions at this point. And it does look similar to the quadratic that we solved before. So either 2x minus 1 was equal to 0, or x plus 2 was equal to 0. So here we would get, again, x was equal to 1/2, or x is equal to -2. And as we checked it in the last one, I'm not going to check again, but the purpose of this, again, is by seeing that method number 2 is we'd multiply all the terms by the least common denominator, and if we do that correctly, all the fractions should go away.